Hello everyone, today we are going to solve the problem insert in middle of the linked list. So in this we are given with a head of a single linked list and the value x. So our task is to insert the key in the middle of linked list. So if you see the first example, the linked list is 1, 2, 4. So head is 1 and the x value is equals to 3. So as we can see, the length is odd. So we need to add after the mid value of the linked list. So mid value is 2. So after the 2, 3 is added. So output is 1, 2, 3, 4. So if we see the even case in the second example, the given linked list is 10, 20, 40, 50. X is equals to 30. So we need to add in between of the two mid values. So 10, 20, the new value is 30 added. After that same 40, 50. So how can we solve this question? So approach. Find length step 1 is find the length of linked list. Step 2, find the previous and pointers. We know previous is one node before the slow node, and slow always moves one step ahead and fast node moves two steps ahead at a time. So if is even, then add the new between previous and slow nodes. So if length is odd, then add the between and slow next node. So that's it. So these are the 4 steps we are going to do. So first we need to find the length. So how can we find the length? We use a length variable start from 0 and a temporary variable which is current, which also start from 0. So while our current is not null, we keep on moving forward. So length will be increased by 1, current will be moved one step forward. So length is calculated. So now we need to calculate the slow and fast pointer and the previous next pointer's value. So previous will be null, slow is equals to head, fast is also equal to head. So while our fast was not null and fast dot next should not also be null. So until this condition, what do? We keep on iterating. So previous is now slow, slow equal to slow move step 1 forward, fast equal to fast goes 2 steps forward. So this is how it is. So now we got the length, we got the previous slow fast. Now if length is even, then what did you say? Create the new node first. New node is equals to new node of what is the value, integer, it is x. So now we said if length is even, add the new node between previous and slow. So previous next is equals to new node That's it. So if length is odd, then we said add the new node between slow and slow dot next. So store the slow's next pointer in a temporary variable, and slow dot next will be new node. New nodes next will be the same temporary variable. So again return the same head value. So this is how we are going to solve this problem. So if you see, sorry we didn't have to use semicolon there. Sample test case is passed. We can see the error is occurred at line number 30. So previous dot next is equals to new node. So we keep it as head. So we need to handle one case. If already the head is equals to null, then we can't traverse anywhere. So directly return the newly created node. So it is better to create the new node over here. So our logic becomes simpler. So simply return the new node. Sample test case is passed. Hidden test cases are also passed. So if you see the code complexity, this loop takes big of n. Again, this loop takes big of n, and remaining are just big of one only lines, and some lines take off big of one space. But anywhere we didn't use any big of n space. Here also we used big of 1 because there are simple some variables which doesn't depend on the size of input. So if you see, the time is equal to big of n, space is equals to big of 1. So here big of n, here big of n, but internally these two loops are independent, so they are added together but not multiplied. So big of n plus big of n is again some n value, so big of n. So the time is big of n, space is big of 1. So the expected are also same. So our code time complexities are matching. So the problem link is given in the description. Please go and practice the problem. Thank you for watching.